So I was going to tie everything all together, but capacitors get a little bit confusing as they discharge because the current is going down and the voltage is going down, and everything is going down because we have a lot of things going on. So let's just do another example problem. Suppose I take a 100-watt light bulb. And I'm going to hook that up to my voltage source from the wall, which is 110 volts. Okay, so I've got P equals IV. So my power is 100 watts, and I want to solve, and I know my voltage, so I want to solve this for current. So I got 100 watts divided by 110 volts, and so that's going to draw a current of 0.91 amps. Okay, now I also have V equals IR, and so now let's solve for R. So R is V divided by I. So my voltage is 110 volts and my current is 91 amps. So I got 110 divided by that, and I get 121 ohms. So that now has a resistance, so it is drawing 0.91 amps of electricity, and it has a resistance of 121 ohms. And where do I want to go from here? I can say that I is change in Q over change in T, and so it is drawing 0.91 coulombs every second. Now one electron is 1.6 times 10 to the negative 19th coulombs, so that is drawing 0.91 divided by 1.6 times 10 to the negative 19th. That's drawing 5.7 times 10 to the 18th electrons every second. So it's drawing 5.7 times 10 to the 18th electrons every second. Now, let's see if I can figure out what the resistivity is really quickly. I don't know if I'll be able to find it, and I should probably have done this other than, but the thought just came to me in my head as I was doing it. I'm looking up in a book, resistivity, and it's got a table on page 576. And tungsten has a resistivity (5.6 times 10 to the negative 8th ohms per meter). Okay, so now we know our resistance is 121 ohms. So we know R equals rho L over A. Now let's think about a light bulb here. I'd say that a light bulb is it's got a spiral, and let's say that spiral, let's make it up. Let's say it's 4 centimeters long. So our L is 4 centimeters long. So our A is going to be R divided by rho L is going to be 121 ohms divided by our rho, which is going to be 5. No, I flipped that. I got it wrong. I flipped it upside down. Let's go to a new sheet of paper here. So R is rho L over A. So A is going to be rho L over R. So we're going to get 5.6 times 10 to the negative 8th ohms per meter times my length, which is, we're going to say 0.04 meters, divided by our resistance, which is 121 ohms. So we're going to say our cross-sectional area is going to be 5.6 to the negative 8th times 0.04 divided by 121 is going to be 1.85 times 10 to the negative 11th meters squared. And you go, that's really small. And it is really small. So that's, assuming our wire is a circle, that's going to be pi r squared. So that means that r is going to be area. It's going to be the square root of the area divided by pi. So my radius of my wire is going to be the square root of my answer divided by pi. And I'm going to get 2.4 times 10 to the negative 6 meters, which is going to be 2.4 micrometers, which is going to be really, really small. But if you think about it, that wire inside of your standard light bulb is really, really small. Okay, so I think I've sort of exhausted that to death, but just sort of, and we're going to do basically all of chapter 18 is going to be more of this, but we're going to be talking about circuits, so it's going to have a little bit more practical value. And the last thing I want to do is I want to come back in the next video and talk about some other units in electricity.